Hi all, good morning, good afternoon. My name is Sarik, and today we are going to discuss about the VMware vSAN, the deep dive session, and I will explain about the vSAN stuff, the technical strategies about like how vSAN works and what is about, what we can do, and what all the features we have with this. So let's proceed. So as you know that in physical world we were using the traditional storage. So in traditional storage we had fiber storage, FCOE, iSCSI, or the local storage or NAS. So on top of that we created VMFS or NFS data store for VMware virtualization and since due to this we had a lot of challenge like the speed issue, congestion issue with the storage path. Sometimes storage has high CPU utilization, and because of that storage degraded its performance, and because of that we had latency issue on the VMs or the servers itself, right? So these are the the issues with physical storage. There is a distance in between server and the storage, and because of that we had a lot of issues in the data center or the server end, and where user were facing a lot of issue in terms of performance and latency. So we do have these many storage which is available, and what all the features we had with such kind of storage. Let's say if we talk about the fiber channel, we had these many capability: the boot from SAN, vMotion, HADRs, and the physical RDM disk, RDM learns. We can get the same from FCOE as well as from iSCSI. So these three storage has these many capability. If we talk about NFS, NFS has some limitation. It has only vMotion, HA, and DRS. These features we can use with NFS. And if we talk about the local storage, it has only the vMotion capability and the physical RDM disk capability. So there are some limitation with the traditional storage, but in with vSAN, which is a virtual storage, we had a lot of the capability, and we reduced a lot of issues in comparison of the traditional storage. So we will discuss about that in details. So what is vSAN? vSAN is a software defined enterprise storage solution which provides hyper converged SCI solution. It's fully integrated with VMware vSphere as a distributed layer within ESXi hypervisor. As we can see here, we had vSAN, vSphere layer, and then on top of that we had vSAN. So it's a combined HCI solution, hyper-converged infrastructure powered by vSAN. So we can use vSAN ready node, the physical ready node, vSAN ready node, or we can add our ESXi host where we need to attach local disk within the blade, and all those local disk can be used for the vSAN now file system. So we will discuss about the architecture and other stuffs, and what will happen when we had the local attached storage within the server. It will use, or it will use the existing local storage, and it create a vSAN vSAN pool, and on top of vSAN pool we will have a dedicated data store, and in that data store we had a vSAN file system such like that. And it is a policy based policy based vSAN. So what we can do, we can create a lot of customized policy, or we can use the default policy which has RAID 1, RAID 5. So we will see in the next slide. So let me proceed. The next question is why we need to use this vSAN. So these days we are using this vSAN in software-defined data center, which is a fully stacked, fully integrated, and is SDDC stack and available today. We don't need to learn. We don't need new tools to learn, vCenter is familiar with this tool, and we can manage this tool from the vCenter layer itself. The deployment and the flexibility is there with private cloud or public cloud. We had SCI solution, as well as I explained earlier, that we can get the vCN ready node, or we can get the SCI solution from the different vendor, and we can use that. So it depends. Either we need to create vCN within a private or public cloud in on premises, or we can get the pre-configured vSAN SCI solution from vendors. We will have the best performance and the VM consolidated workloads. So these are many benefits of the vSAN, and a lot of people and a lot of accounts across the world is using the vSAN in these days. It is just like the demanding product where we need to people are adapting this within their environments, and they are taking benefits and having these many benefits within the environment. It's agile. The scalability is it is highly scalable, and people can extend the data store size within minutes. So I mean, these many things we can do, which is a very pain point, with traditional storage. If something happened in the storage side, we had to wait, and there would be a downtime. But in vSAN, we had a more availability in terms of it will increase the availability, and we can see the use case also. We are using this vSAN in VDI, cloud native apps, container, the remote office branch, office branch office, or I mean the small and medium remote office, management cluster, disaster recovery, database, SQL, Oracle, or the business critical application. So in short, I mean, we can use vSAN with most of the things which is available in these days, in today modern days. So it is compatible with all of the technology. And let's go back. So in vSAN, as I explained, we can scale up and scale out this. If we can add more ESXi hosts within the cluster, we can add more disk within the ESXi, and we can scale up the data store size, vSAN data store size. We had two type of vSAN which is available from the 6.x. So we had hybrid and all flash. So in a hybrid, what is gonna happen? We need empty disk, and the empty disk is for capacity, and the SSD disk for cache drive. So it's a hybrid mode. And when we saying all flash mode, so in that we need all disk as SSD, where we will have the cache disk and the capacity disk. So when we had all flash vSAN within the environment, it will provide more millions of IOPS, and we will not have any performance issues. So as VMware also recommend to use the all flash vSAN within the environment, and it will provide the best and better performance with the storage from the storage perspective. We do have some cluster sizing, like what we need. So minimum 3 ESXi host is required within a cluster where we can enable the vSAN. We can also open this link and get the design, and we can size the vSAN cluster as per the requirement or the use case. We can have maximum 64 ESXi host. We can also have minimum 3 ESXi host within a cluster for a stretch cluster, where we can have 15 maximum per site and one witness node. We can have 6,000 there is minimum is none, and the maximum of the number of the VMs we can have 6,000, which would be HA protected within the cluster. We would have one disk group per ESXi host, that is a minimum, and maximum is 5. So again, for cache disk, we need one cache disk, and maximum 5 cache disk we should have. And based on the calculation, we can see here we would have one capacity disk as a minimum, and maximum is 35. So we can divide 35 by 5. So we should have 7 capacity disk per disk group. So 5 disk group, 5 into, sorry, yeah, 5 disk group into 7, like that we should have. So this is about the the sizing, how we can calculate, and if you need the more insight, you can go with this link and you can calculate capacity with the sizing and all, the number of ESXi hosts and number of VMs, number of disk group. Those things can be resized. I mean, we can calculate that. Also, we had VSAN cluster requirements. So in that we need, as I explained earlier, we need one SSD for caching, one SSD for capacity. That is a minimum. That is a minimum requirement. We should have 10 GB NIC for all flash. If we are going to use hybrid VSAN mode, then we need minimum one gig NIC. Otherwise, we would recommend, or VMware already had a recommendation of 10 gigs NICs. For VSAN cluster, we can use controller as well for the disk. So we can use SAS, SATA controller, and it should be in pass-through mode or RAID 0 mode. Then only we can use those disks into the VSAN configuration. We had VSAN versions, so as a lot of people already knows that from when vSAN got launched. So from 5.5, we had vSAN launch from the VMware side, and now we had, after 5.5, 6.0, 6.1, 6.2, 6.5, 6.3, and the latest one is 7.0. We can also see like what all the license we have with vSAN is standard, advanced, enterprise, robo, and the advanced for robo and enterprise. I mean, we have these many type of license with vSAN. vSAN licensing was available from 5.5 U1 and after version. And in vSAN 6. From vSAN 6.0, we had all flash architecture with vSAN, and before that we had only a hybrid mode. So that's about the vSAN versioning and all. About the vSAN disk type, if we used HDD or SATA disk for capacity, it will have less RPM. However, if we use SSD, we can see how many cycles we had. So we will have, more IOPS, best performance with SSD. So it will increase the speed. However, it is very costly, but yes, it will provide the better performance in terms of the SAS or SATA disk, which we were using in a hybrid mode. So that is the difference in disk type. We had vSAN file system. So in 5.5, we had VMFS -L file system. Now from the 6.x, we had vSAN file system. So we can see in 6.0, 6.7. I mean, with from the 6.0 to latest version, we had vSAN file system, which is using for vSAN data store. And if we talk about the other data store, which is coming from fiber storage or NFS, NAS storage that has VMFS or NFS kind of file system, but vSAN has its own dedicated file system, which is a vSAN file system. We had deduplication and compression also. So with if we enable, I mean, that option is there. In latest version, it is enabled by default, but in previous version, it was disabled. So we need to enable it manually. If we use deduplication and compression on top of the vSAN data store, it will reduce, and it will do the compression, and it will save the space at as much as 7 times in comparison of other file system or other kind of storage provider. We had since we said that vSAN is a policy-based, policy-driven, software-defined storage solution. So we can create vSAN policies, and these are the parameters we had. We had RAID 1, RAID 5, And in RAID 1, if we are going to use the RAID 1 in a VSAN policy, so we should have these many of ESXi host number which is required. We should have these many capacity, this many of host this kind of calculation, and how much capacity we will have in RAID 1 if we are using the failure to tolerant 1 or 0 or 2 or 3. So based on the PFTT, we need to we should have the number of ESXi hosts within the cluster. And you can see RAID 5 had less consuming less space, and it is saving 50%. If you're using RAID 1, then we will have 33% uh, less utilization. But yes, in RAID 5 we can use also RAID 6. So it depends on how we are gonna configure the VSAN policy. For RAID 5, we need minimum 4 ESXi hosts, as we can see in this slide from the left side. And it will provide single, it will have 4 replica on 4 different node. So if one host goes down or got failed with XYZ reason, then we will not face any issue, because it will tolerate the single failure. If we had RAID 6, then it will tolerate double failures. So if 2 hosts at the same time goes down with XYZ reason, or this group got corrupted, or any other issue occurred during some point of time, then it will not create any issue on top of the VMs. VM will be available, and those will not have any impacts in terms of the availability. So we can see the formula is there, 2n plus 1 host contribution is stored, and the default value is 1. When we say 1, then it will use the RAID 1 by default. And as soon as we had more ESXi hosts within the cluster, it will gonna change, or we can create additional policies based on the requirements. So in vSAN data store, we had five category here. So VM home namespace, VMDK, VM vSwap, VM swap, snapshot delta, and VM memory. So these 5 vSAN objects get created, and these 5 objects has these many of VM files, like it has vmam, delta.vmdk, vswap, plat, and the VM home namespace has nvrm, vmsd, vmx, vswap, and log file, and all these things. So, and we can see also, like these many objects having such ABC policy, and these many objects residing on different ESXi hosts within the different disk group across the ESXi host within the cluster. This is a VSAN architecture, so we need a physical, how this VSAN is working. So it has cluster, CLOM, DOM, LSOM, and the CMMDSS. So each service has their own responsibility, what they had to do. So you can go through with that. So we can see cluster level object manager has capability or duty, these kind of things. They will make sure that placement of the objects or the migration will happen, and the component should distribute across the ESXi host within the cluster. DOM will make sure the paths for the objects, and if something happens, then it will also handling the errors. It will notify to the clones, and clone will take create the notify and get the alert created within the for such kind of events or errors based on the situation. Helsom will report the events for the device or the disk state if something happen, or let's say if any vSAN object has a recovery or the degraded state or the failed state. Any kind of issue with the vSAN object or the physical device itself. So these are the things it will manage. Then we had cluster monitoring, membership, and directory service. So it will make sure that cluster should have sufficient node members. If one node is going down, so it will elect the master. and it will make sure master and the slave, concept within the vSAN cluster or architecture stuff. We can also review this good picture, which is pretty good and explained, in the detail, like how things happens in the vSAN architecture in the backend. We had the cluster design stuff, like we need to make sure that we, before enabling the vSAN, we should have HA enabled, and all the ESXi hosts should be, they should have HA configuration properly. If any of the ESXi hosts having issue with the HA configuration, we need to fix that first, and then we can enable the vSAN. The same concept will work if we are going to disable the vSAN. Then first we need to disable HE, and then only we can able to disable the vSAN. That is tricky part, but yes, this is the requirement, or this is a concept, like whenever we are going to design the vSAN. vSAN also require vSAN network, a vSAN VM kernel adapter we need to create. So that is a networking stuff. So for each ESXi host, we need to make sure we had a vSAN VM kernel adapter, and while we are going to, configure the vSAN. So these are the, we can consider these as a prerequisite. We should make sure what disk we are going to use in hybrid mode, what is the cache disk size, what is the capacity disk size, and the capacity disk size should be match. All disk across all the ESXi hosts should be with same capacity. Same thing in all place vSAN all place architecture. So the cache tier, disk, and the capacity tier should have the same capacity disk size, like that. We can have this VMware link also. We can go through with this, and it will give you idea like how we can define this, or how we can do this vSAN sizing whenever we are gonna architect of a vSAN cluster. What all things we need, what is the size we need to we should have for capacity, what size we should have. So it's kind of a simulation. You can go through that, and you will have hands-on experience, like how you can play with this vSAN sizing stuff, or things, how you can decide how much data store you are gonna plan, and what all the disk you had, and how many number of disks you need for cache and capacity for such kind of. This is about the configuration of vSAN. So what we need to do, it's a pretty small, so we are not able to see here, but yes, I can explain. So we need to select a cluster. We should have minimum 3 ESXi hosts, and then we can go in configuration tab, and then we'll click on the configure. We will enable the vSAN. We can select single site and two host vSAN cluster, stage cluster, based on the requirements, what type of cluster we are going to create. So let's take example of single site cluster. We can enable deduplication and compression, which we just go through in previous slide. And then we had to define the capacity disk and cache disk accordingly, or we can select manual option also. So after enabling the vSAN, you can create this group later. So that options are there. So like this, in 4 simple steps, you can enable the vSANs. We had vSAN maintenance. So we do have 3 options of the vSAN: full data, ensure accessibility, and no data migration. So I put it here very good with pictures, so you can have understanding. While we using full data migration, it is well self-explanatory. So whenever we are replacing a host with the maintenance, we will select the full data migration, and it will make sure all data evacuate to and move to other ESXi host disk groups. So it will make empty entire host. So we can consider this situation when we are going to decommission of a ESXi host from the vSAN cluster, or when we had some kind of trouble, let's say disk group having issue or disk got fail. In critical situation, if we are going to use we are going to place host in for a short period, let's say for patching or for some troubleshooting where we are sure like it will not take much time. So that time we can use ensure accessibility, and it will make sure whatever all powered on VMs are there, those components, vSAN objects and components will be available on the remaining of the ESXi host within the cluster. Then it will place that host in maintenance mode. It will not migrate objects for the powered off VM. That is the difference in ensure and full data migration. And the last, and which is not suggested, that is a no data migration. So in case if we had a lot of issues within the environment, if we are not able to place host with ensure or full data migration, in the last situation when we don't have any option, then we can select no data migration. But there would be some chances like some VM goes in inaccessible, or some vSAN objects become unavailable during this no data migration option. So we will not suggest to use that. Just use the ensure accessibility for short period. If you're going to place host for longer period or going to decommission, then use full data migration. That is my presentation. Thank you, guys.